All right, this is a video to go over some of the 1A material that we're going to be behind schedule essentially because we're missing the first Monday in the 8 weeks. So we're going to look at having some of this in a video format to make sure we are going to stay on track. So the first topic in 1A, 1A.1 is the first subtopic here, is rounding, decimals, fractions, and percentages. So rounding a number is a process of reducing the digits used in a number while trying to keep the rounded number similar to the original number. You will need to know place values to identify the digit you are considering. See the place value chart below. So we're going to look at this a little more in depth. Okay, so we have this, and this is kind of split into two parts, mainly so we can just focus on whole numbers versus what do we do if we have decimals. So if you have a whole number, remember that's a number that is greater than zero. Essentially, zero is also a whole number, and it doesn't have any fraction or decimal parts to it. So in our whole numbers, we have these place values. So we have to the left of our decimal value, or if your decimal's not there, this would just not be drawn. We would have the ones place value, the tens, the hundreds. Notice that is a group of three that we consider the ones. Then we have the thousands, 10,000s, and 100,000s. Notice those are repeating this pattern of 1,000, 10,000, 100,000. So those are the thousands. And we have millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillion, 100 trillions. So if I was to write a number in here, let's say 30257160735. So I just kind of made up a number as we go. So anytime we get to those groups of threes, we can think about that's where our commas would go. So from your decimal, every group of three, we put a comma in front of that. And then we can read this off. So this is 30 billion. And then this is 257,160,735. Okay, so that is how we would read that value. Now, if you have decimal points, so your ones is here, and let's say we have something after the decimal. So I'm going to put a 0 in for the ones place, just for this specific example. You don't have a 1th place. Notice that all decimal value place values have a THS as the ending, okay? So we don't have a 1th, we start with the 10th. So 10th, 100th, 1000th, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth, and billion. So that's as far as we would go in this scenario, okay? So say we have 1, 2, 3, 4 here, just making up numbers. This would be 1,234 10,000ths, okay? So that's how we would read that. So rules for rounding. We want to locate the digit to which the number is to be rounded. Ignore all digits except the one immediately to the right of this digit. So when we're talking about that, let's say we want to round to the nearest 100, not hundredths. So we're rounding to a whole number. So let's say my number was 736, okay? So when we're rounding to the nearest 100, we want to locate the place value for the 100, that's this value, and we're going to look at the number directly to the right of it to determine if that's going to make our 7 stay a 7 or if it's going to bump up to an 8. So that's what we're talking about in that first part right there, okay? If we're rounding to a whole number, remember that means a place to the left of the decimal. If the digit is followed by a 0, 1, 2, 3, or 4, then round the number. We're not really rounding it down. You kind of are, but we're just leaving the digit as it is, and we're placing all the digits to the right with a 0. So you are rounding the whole number down, but you're not rounding the actual digit down right there, okay? So that one right there would fall under that category. This one right here would be 700, okay? Because the 3 is a 0, 1, 2, 3, or 4, so it does not make that 7 bump up to an 8. If the digit is followed by a 5, 6, 7, 8, or 9, we'll round that number in front of it up by increasing the digit by 1, and then all the numbers to the right, all the way down to the decimal point, will become a 0. So if we had, say, let's put another one up there. Round to the nearest 100, and let's say my value was 1,257. So again, I have more place values than 100 here, but we're rounding to the 100. So we're going to find that value that's in the 100 place. And then we're going to look at the digit right behind it, which is a 5 this time. So that's going to bump that up to a 3. The 1 is still in front of it. And then all of the digits to the right of the 3 become a 0. So 12 or 1,257, or you could say 1,257, rounded to the nearest 100 is 1,300. Okay. If we're rounding to the place of a right of a decimal value. So this is where things can get a little bit different because we're rounding something into its decimal place values. So let's say my example is round to the nearest, let's say 100th. Notice the TH, okay? And let's say that my value I have is 0.125, and I have another one that I'm going to round to the nearest 100th, 0.132. Okay, so those are both going to get rounded to the nearest 100th. Okay, so when we find our 100th place value, remember there is no 1, so this is 10th, 100th, so it's that second place on both of those. If we look at the digit behind it, that'll determine whether we change the 3 or change the 2, whether or not they're going to change or not. So a 2, 0, 1, 2, 3, or 4, if that's behind your digit that you're rounding to, you do not change this. It would just be 0.13, and we drop off any values to the right of our rounded digit, okay? So you don't add zeros in there. That's different because when we had a whole number, if you dropped off the numbers, you'd be changing it just to 13, and that's not what that rounds to. So when you're in the whole numbers, you do have to add in those zeros all the way down to the decimal point. But when you're rounding to decimal form, you drop off the remaining digits. So for this one, this would bump up to 0.13, and we would drop off that last digit, okay? So they both have the same answer, but this one is because this is followed by a number that doesn't make it round up. This one is followed by a number that makes it round up, okay? All right, so let's look at some examples. So if you're rounding to a place that's to the left of the decimal, fill in all the places from that decimal point to the rounded value with zeros. That's what we just talked about. So 57,492 to the nearest hundreds. That would be rounding the 4 based on what's behind it. So that's going to round up to a 5. And then remember, we put in the zeros after it. If you're rounding a place to the right of the decimal, round and remove any of the digits after. So if we're rounding 0.9367 to the hundredths place, that's going to be this digit. When we look behind it, that 6 will bump it up to a 4, but we remove the remaining digits, okay? So here's a little table for us to practice this. Round to the indicated place value. So here's our original, 437.2593. We're going to round to the nearest 10th. So we're going to underline the correct place. That's the 10th place. Remember, it's one digit after the decimal. We're going to identify the value directly to the right of it and say, does that round that 2 up or keep it a 2? So since it's a 5 and above, it's going to round that up to a 3. So this would be 437.3. Okay. Round to the 1,000. Notice not the TH. So 1,000 is, let's see, 1, 10, 100, 1,000. That's that 9 right there. So there's a 4 behind it. That will not change the 9. So that's going to stay a 9. So this will be 4, 8, 9. And then when you're rounding to the whole part, not a decimal part, you put zeros all the way down to the decimal point. And now you do not need to continue past the decimal. This is going to round to a whole value since we're rounding in a whole place value. Okay, so it's 489,000. The 1,000th is a decimal place value. So this is 10th, 100th, 1,000th. So it's that 3. The 10,000th place is behind it. That's going to determine if that changes from a 3 to a 4. It will not because that is a 2. So this one will be 437.253. Rounding the next one to the nearest 100th. So 10th, 100th, notice that's a 5, behind it is a 2, so that's also not going to round that up. So this would be 1,234.25. All right, let's talk about this one. This one's a really interesting, the 10,000th. So the reason this one's interesting is what we're going to see is something called a rolling 9, which is a repeated kind of rounding thing. So we need to talk about what happens when you see that. So this is the 10th, 100th, 1,000th, 10,000th. Right behind that is a 9. So a 9 is a 5 or bigger. So it's going to bump my 9 that's in my 10,000th place up to a 10 because a 10 is the next digit up. But we can't put 2 digits into a single place value. So what happens here is that you put the 0 of the 10 in this spot, and we add the 1 to the next spot in front of it, to the left of it. Well, it just so happens to also be a 9. So that would add 1 to that, and that would become 10. And then we add the 1 again. We have to bounce it up. So this one's going to be a 6. So that's kind of a rolling round. When you have these 9s in a row, if one of them rounds up, it's going to round all the 9s in front of it until you run out of 9s, essentially. And then that rounds up that last digit right in front of it. So this will be 437.26. Now I'm going to go ahead and add 2 zeros here, not because it's necessary for it to be the right digits, but because they asked me to round to the 10,000th place. So I'm actually showing that that's the 10,000th place. It's just ended up being 2 zeros there because of those rounding steps. All right, and then the last one in this group, we're rounding to the tens place. So that's this 5 right here, and there's a 3 after it. So that 3 is not going to bump it up, so it'll still be 450. We add a 0 until the decimal point. Remember, when you're rounding in a whole place value, which means you don't have the TH, you're going to need to keep those zeros going all the way down to the decimal point. When you're rounding to the decimal point, which has the TH, you would stop at the place value we're rounding to and drop off the rest of the digits after you've rounded, okay? Rounding with repeating decimals. So 1/3, if you type that into your calculator, you'll see that it is 0.3 forever. So any place value that I choose to pick, so if I said, let's round to the 1,000th place, there's always going to be a 3 behind it. So it's always going to just truncate at a 3 because that's not a 5 or bigger. So that's why I wrote here, if you're rounding to the tenths, it's 0.3, hundredths, it's 0.33, and the thousandth, it would be 0.333. And it would keep going if we keep moving out. Now, the 2/3, which is a 0.6 repeating, no matter where I stop in this lineup, there's always going to be a 6 behind it. So it is going to round the last place. This, whatever we stop at, the 6 will bump that up to a 7. So if you're rounding to the tenths, you would just get a 0.7. If you're rounding to the hundredths, you'll get 0.67. If you're rounding to the thousandths, you'll get 0.667, and so on, okay? Now, another thing we want to talk about is converting between fractions, decimals, and percentages. So to convert a fraction to a decimal, you'll divide the numerator by the denominator and round to the nearest thousandth if needed. So that's our directions. So 4 divided by 5. Now, the old school way of doing this would be to take your piece of paper, and you're going to say 5 goes into 4. It doesn't go any. So we add a decimal and add a 0, and then we say 5 goes into 40. That's going to be 8 times. And we would do the long division. So it's going to be 0.8, but we have calculators available to us in this course. So let me make sure I'm sharing full screen. Yep. You would just type this in on your calculator. 4 divided by 5 is 0.8, so 0.8. So this one doesn't need to be rounded. 5 divided by 7. Now I'm going to write this out to quite a few decimal places, then we'll round to the correct spot. So it's 0.7142857. Let's write that much. So 2857, and I can put ... to mean that the decimal goes on forever. We're supposed to round any of these that didn't come out nice to the nearest thousandth. So 10th, 100th, thousandth, look at the digit behind it. That is not going to bump that 4 up. So this is approximately, notice they put that instead of equal to, 0.714. Okay. Let's do the next one. 29 divided by 72. I'm going to write this out like again to a few decimal places. That would be 0.4027, and there's a bunch of 7s forever, ... Notice that my calculator does round the very last spot to 8 because it can't hold any more digits. This is still going on forever as a bunch of 7s. So if we round this one to the nearest thousandth, 10th, 100th, thousandth, that's a 2 right there. The 7 behind it will bump it up to a 3. So approximately 0.403. Okay. Now, let's go the opposite way. Well, actually, before we go from decimal to fraction. So we're going from fraction to decimal, then we're going to go from decimal to percent, and then we're going to work our way back and forth between some of them. So to go from a decimal to a percent means per 100. So there's a couple ways you can think about these problems. You can move the decimal 2 places to the right, or you can think about it as multiplying by 100 and adding your percent symbol. So I like the decimal movement. It's really quick. So if you're trying to turn a decimal into a percent, you move your decimal 2 places to the right, add any zeros as necessary, and add a percent sign. So that would be 80%. 1.3, move the decimal 2 places to the right. That's going to have a 0 added on. So that's 130%. 0.042, move the decimal 2 places to the right. Notice that that still gives me a 4.2. So my percent would also still be a decimal. So 4.2%. To convert a percent to a decimal, you go the opposite direction. So you move your decimal place 2 places to the left, or you can think about this as divide by 100 and remove the percent symbol. So I like to move the decimal. I think it's easier. So if you don't see your decimal, it's at the end of the digit. So if I'm moving this 2 places to the left, 47% as a decimal would be 0.47. 19.2% turned into decimal form will be 0.192. And it is up to you whether you write the 0 point. You have to write your decimal point, but I like the 0 because sometimes decimal points, when I look at people's scratch work, they're not very clear. Okay, so sometimes having that 0 point helps me see that that is your decimal. And then 4% would have its decimal at the end again. So we'll move this 2 places to the left and add a 0. So 0.04 is 4% as a decimal. All right, let's look at a couple more variations of how to change between formats. So if I'm at a percent and I want it in fraction form, well, we just said a percent is per 100. So all you have to do is write your percentage over 100 and then simplify this. So 47 over 100 is actually already reduced. There's nothing that goes into 47 that also goes into 100 as a factor. But if you put 36 over 100, that is reducible because they're both divisible by 4. Let's see if that's the biggest thing. 36 divided by 4 is 9. 100 divided by 4 is 25. 9/25 is as far as that reduces down. Now, in class on Wednesday, I will try to make sure and show you kind of, there's a button on your calculator. We can go through it with everybody that if you have a scientific calculator, a lot of those will reduce fractions for you. It just depends on the brand if it does it or not, okay? And then to convert a decimal to a fraction. So write the digits, leave out any zeros immediately to the right of the decimal, over the place value and reduce. So 0.057 is 57 thousandths. You're looking for what is that last place value, okay? So 57 over 1,000, and then we would see if that reduces. So this one is the 100th place. So that's going to be why when I write this, I write it as 14 over 100. So it depends on what place value that last digit's in. That tells us what our denominator is. And then we would try and reduce this. So these are both divisible by 2. That would be 7 over 50. Okay. This is in the 10th, 100th, 1,000th place value. So I'm going to put 124 over 1,000. And this looks like it would reduce. Let's see, 124, I think is divisible by 4. Yeah, if we divide both of these by 4, let's see if that gets it reduced. So 124 divided by 4 is 31. 1,000 divided by 4 is 250. So 31 over 250 is as far as that reduces. And then this last one we have, this is 2. It's also still in the 1,000th place value for that last digit. So that's 2 over 1,000. We reduce that, that's 1 out of 500. Just divide them both by 2. All right, and that completes 1A.1. So the second part we needed to do for this missed class is the 1A.2 section. It's pretty short, it's only 1 page. And then that'll be everything you need for us to start our 1A3, 1A4 notes for class on Wednesday. So ratios, writing as fractions, and using an application. So comparison of relative size of 2 quantities. They can be written in a variety of ways. So you could say 4 to 5, that's actually read as the word 2 as well. This is a colon, 4 to 5 and 4 over 5. You can also write that in its decimal form. 4 divided by 5 is 0.8. Now, when you see that and they're talking about that as a ratio, anytime you just see a value and they say, is it a ratio? Like, how do you write that as a ratio? It's per 1. So this would be 0.8 per 1. So essentially what they did there is they divided the top and bottom of this by 5. So on top we get 0.8, on the bottom we get 1. Okay, so that's kind of how that becomes a 0.8 per 1. So just as an FYI there. So a survey of 4,200 dentists about their preferred toothpaste found that 3,600 preferred Crest. Write the ratio of dentists that prefer Crest. Okay, so we have to write it in the order they tell us to all dentists surveyed. So the ones that preferred Crest was actually the 3,600. So that needs to come first. And then the all dentists was 4,200. So we want to write it first as a fraction in simplified form. So 3,600 over 4,200. When you're reducing fractions that end in groups of zeros like this, you can reduce out and cancel out the ending 0 if they have the same number of ones, or just think about it as you're dividing by 10, and you divide by 10 again. So this first reduces to 36 over 42 because they both have zeros that can cancel out. Again, has to be a matching 0 at the end for each one. And then 36 over 42 are both divisible by 6. So if we divide this by 6 on top and bottom, that's going to be 6 over 7. Okay, so that's as a simplified fraction. As a decimal rounded to the hundredths, okay, so we need to take our calculator. 6 divided by 7. I'm going to write this out here to the side, 0.857. We're just going to get a few digits, 1428, ... Okay. To the nearest hundredth is going to be that second place after the decimal, and there is going to be, we have to look at the digit behind it. So the 5 is going to get bumped up to a 6 because of that 7. So this is approximately 0.86. Okay. As a percentage, well, we move the decimal 2 places to the right, and we would say that's approximately 86%. All right, let's look at another example. Find the patient's ratio of total cholesterol to HDL cholesterol using the given information. The total cholesterol is 232 milligrams per deciliter, and the HDL cholesterol is 68 milligrams per deciliter. Answer with a simplified fraction. Okay, again, look up here, total cholesterol to HDL. So this is numerator to denominator. So just because you see HDL being smaller doesn't always mean it's going to be written on top of the fraction. It has to do with how did they list it in the ratio directions. So total cholesterol is 232. HDL was 68, and we're not supposed to turn this into a decimal. We're supposed to reduce this. So I know we can probably divide by 2, but let's see if we can divide by 4. Looks like we can. And this may or may not get us all the way reduced. So again, I don't have the special calculator on my computer to do that. So that would be 58 over, let's see, 68 divided by 4 is 17. We'd also want to check just to make sure 58 is not divisible by 17. It is not, and there are no other factors that go into 17. So this is 58/17, okay? Now, if you really did want to look at, like how is that person's health, you probably would want to turn it into a decimal or something like that, okay? But that's just how they wanted our answer. All right, and that ends the notes that we would have done during a Monday class if we'd had one for this first 8 weeks. You do still have some pre-video information, so just make sure you know how to navigate in our course. So let me pause real quick my share, and I'm going to pull up our course in Ivy Learn and just show you really quick. Let's see, yeah. So let's go to our home page for our course. And what you'll notice is that there's weekly class note templates. That's where I post all of my Word and PDF files for the notes that we do in class. It's also one place where I will post the weekly video assignment. We'll talk more about that on Wednesday because there's actually a badge incentive and some other things that are tied to all of the weekly stuff. So one of the things you'll notice is if you go into week 1, it'll tell you right at the beginning, there is a weekly video assignment every single week that we're not testing. So pretty much weeks 1, 3, 5, or excuse me, 1, 2, 3, 5, 6, 7. Weeks 4 and 8, we're testing on midterms and finals, so we won't have a video assignment those weeks. But that video assignment has a Word format and a PDF format. and it tells you what videos that you need to watch. So if you go into the actual assignment at the bottom, that's where you'll find this. It's a little bit easier. I need to make sure I've got it linked to the right video. But this is the video that needs to be watched, and notes need to be turned in before Friday at 11:59 p.m. And then we'll talk about the badge system in class. But this is something you also want to be watching because we only have an hour and a half instruction in a virtual 8-week course for each class meeting. There is that online, I put it in the announcement I sent out, there's an online component which I do as video notes that you have to submit to me so that I know that you've done all of your videos for the week. Okay, so that's everything. I look forward to seeing everybody on Wednesday.